Hey everyone, welcome back. On behalf of Forge College, I am super excited to jump right into another explainer with you. So in our last lesson, we really pushed the limits with high-frequency transactions. We're talking packing accounts, batching, just optimizing for pure raw speed. But today, we're pivoting. We're facing a brand new challenge. We're going to take that lightning-fast code and give it a massive blueprint makeover so it can actually survive a professional review. Because, let's face it, we're going head-to-head with the ultimate boss of Solana programming, the auditor. There's this great quote, "Account packing is great until you force an auditor to guess what's inside the box." And wow, is that painfully true. We might build this brilliantly optimized monolith that runs at absolute light speed, but if it's just a tangled ball of logic, it's a total nightmare. It's literally like handing someone a perfectly tuned sports car, but every single wire under the hood is painted the exact same color. I mean, good luck figuring out what does what, right? All right, let's dive right into this. Here's our roadmap for this renovation. Number 1, the need for auditability. 2, decoupling instruction dispatch. 3, splitting the monolith. 4, the 5-step workflow. And finally, 5, prepping your capstone. Let's figure out how to keep our programs blazingly fast while making them perfectly organized. Starting off with Section 1, the need for auditability. So this is the core mindset shift we need to make. On one side, we've got our high-frequency focus from last time, speed, account packing, batching, all that good stuff. But on the other side, we have our new modular focus. This is all about readability, clear invariants, and isolated testing. Now, the trick here is that we are definitely not abandoning speed. No way. We're just wrapping those intense optimizations in explicit, clear boundaries. Basically, we keep the incredibly fast engine, but we put the components into neatly labeled boxes so an auditor can verify them without pulling their hair out. Moving right along to Section 2, decoupling instruction dispatch. Okay, so the handler trait is this incredibly powerful Rust pattern that acts as a strict boundary. It completely separates your global input validation from your specific instruction logic. You can think of it kind of like a highly efficient mail sorting facility. The entry point stays super minimal. It's just checking basic global rules, like making sure an incoming package isn't literally empty. And once it passes that check, boom, it immediately delegates the heavy lifting to focused, testable units that we call handlers. It keeps all that messy logic completely out of the front lobby. And doing this dispatching right actually gives us a really strict checklist. First, it enforces top-level validation, like input length. Second, it instantiates generic handlers to make testing a breeze. Third, it ensures absolutely no unneeded state mutation happens at that top level. And fourth, it keeps your account ordering visible right there in the function signatures. With a setup like this, an auditor can just breeze in, verify the global rules, and safely dive into individual handlers without ever losing track of what's going on. All right, on to Section 3, splitting the monolith. When we finally take a sledgehammer to that monolith and the dust settles, we're left with the rule of 3 for instruction handlers. 3 clean modules. We've got validate input, authorize, and mutate state. By forcing our code into these distinct categories, nasty bugs just can't hide in massive blocks of inline text anymore. Validate input handles parsing, authorize checks signatures without touching state, and mutate state is securely isolated to perform the actual writing. Now here is a golden rule you've got to remember. Keep your parsing and validation pure. Return domain values instead of writing to account data in the validation step. Why does this actually matter? Well, by returning plain domain values, think of them as clean, prepped ingredients rather than a half-baked cake, your validation step becomes incredibly easy to test. You don't need to spin up some complex fake blockchain environment. You just run it against simple byte slices. It's clean, it's pure, and trust me, your auditors will absolutely love you for it. That brings us to Section 4, the 5-step workflow. Think of this as our mandatory engineering assembly line. To turn highly optimized code into a truly auditable masterpiece, it has to pass through these 5 stations. Step 1, decompose. Step 2, isolate. Step 3, document. Step 4, test. And Step 5, review. Let's see how this actually plays out in practice. Focusing in on decompose and isolate for a second, the absolute critical rule here is avoiding shared mutable state. That's like 2 people trying to write on the exact same piece of paper at the exact same time. It just causes pure chaos. Instead, pass explicit values through your functions, not unstructured bytes. When you break a massive function apart, write a 1-sentence contract for each new piece. What inputs go in, what outputs come out. Those simple contracts create airtight vault doors between your modules. And Step 3, documentation,
leads us to artifacts exactly like this module table. Let me tell you, this is an auditor's absolute best friend. Notice how it perfectly maps instructions like transfer or initialize to their specific modules. It spells out the primary invariants, like ensuring a sender has enough balance, and it explicitly lists all read and write permissions. It literally summarizes the program's entire behavior at a single glance, with absolutely zero code reading required. For testing and review, we rely on some strict standards. We're talking in-memory mock account info objects, asserting exact byte-level changes, providing an IDL and module tables during review, and logging architectural changes clearly. The absolute beauty of this system is that if you later decide to tweak your account ordering to squeeze out a little more high-frequency performance, these targeted unit tests will mathematically prove your logic is still flawless. The structure might shift around, but the math stays completely pristine. And finally, Section 5, prepping your capstone.
All right, it's time for the capstone pre-flight checklist. First, collect all those modular handlers we just designed. Then, write out those concise, one-paragraph module scopes. You also need to document every single required account and the specific tests backing them up. And definitely do not forget to note any specific performance constraints from our high-frequency lessons. Gather all these blueprints together because next time we are turning them into a massive load-bearing Solana program. So, I want to leave you with this final thought. How will you organize your own monolithic chaos into neat, highly auditable boxes for your final build? Seriously, don't wait on this. Take a hard look at your code today and start decomposing it. The ultimate boss, the auditor, is waiting. But if you follow these steps, you'll be completely ready for them. Well, that's all for this explainer. I really hope you enjoyed this deep dive into modular design and designing for auditability. Keep pushing the boundaries of your architecture, and remember to visit forge.college to continue your Web3 learning journey and master even more advanced Solana techniques. Keep building, stay curious, and I will catch you in the next explainer.